This is APES lecture number 3 for chapter 17 and 18. And I wanted to let you guys know about these pollutants that we've been talking about. I'm sorry, I have hiccups. Um, the pollutants, the primary and secondary pollutants, primarily come from um, burning of fossil fuels, and they're much more common. The burning of fossil fuels is much more common in urban areas, rural, or not rural areas, urban areas. And I also want you to know that pollutants can come from natural sources too. And some of those natural things are just dust from like a windstorm. Um, so let's just list these. Also, obviously, volcanic eruptions, they release a lot of sulfur oxides into the atmosphere. And when we talk about oxides, you can just put SOx, like for this one is sulfur oxides, meaning that this X could be a 2 or 3 or nothing, or just one. Um, So sulfur oxides are the main pollutant coming out of volcanoes in addition to particulate matter from volcanoes, like flying ash. Um, Also, forest fires. There are natural forest fires, and when forests burn, they release carbon oxides, nitrogen oxides, and also particulates. And it's important to know that obviously forest fires and volcanic eruptions and windstorms that pick up sediment, soil, and sand are few and far between when compared to the constant input of industrial processes. So in most cases, it's not very harmful because they're so few and far between. But when you couple it with what we do, that creates some issues. It's also important to know that plants give off different types of gases, obviously oxygen, but when they are in reproductive mode and they release pollen, that pollen is um, a particulate in the atmosphere. And if any of you have allergies, I'm sure you know that. They also release hydrocarbons and methane and hydrogen sulfide. The methane and hydrogen sulfide come from the decomposition of the biomass of the plant. So that is another natural process. And also particulates from the ocean, specifically salt. Salt is a particulate matter that can get into the air. Obviously, it's in very small form, but it's in there. So these natural processes are spread out, and so they rarely ever reach levels that are harmful to humans. What I'd like to talk about now is smog, and there's two different kinds of smog. There's photochemical smog, and photochemical smog is associated with nitrogen. It's also called brown air smog. Make sure you write that down. And then industrial smog is associated with carbon, and that is called gray air smog. Um, Industrial smog is more of a gray color, whereas nitrogen or photochemical smog is more of a brown color. Each one of these processes vary um, based on the topography of the land and the industrial processes, the climate, the type of fuel that they use, as you can see here, and population, obviously. So it's important to know how all of these things um, could really paint the perfect picture for smog to develop. Some areas that smog is an issue are areas where the city might be at the base of a valley, so all around the city might be mountains. And a perfect example of that is like Los Angeles, um, Denver, or like Mexico City. And all of those are large cities with industry. And so that really affects it or exacerbates the issue with smog. The first one I want to talk about is photochemical smog. And photochemical smog, the word photo is in it, and that is obviously associated with light. So light from the sun helps to catalyze this reaction to make photochemical smog. You will have to know this process And an easier way to do it would be with the symbols of the elements here. So if you had nitrogen and oxygen, these both come from the combustion of fossil fuels, specifically gasoline, like in cars and automobile engines. They will give off a colorless nitric oxide. So nitrogen and oxygen combine within the engine to produce nitric oxide. And then once that nitric oxide is in the troposphere, it'll react with oxygen and form nitrogen dioxide. So this 2NO will react with oxygen that's naturally in the air, and that will produce nitrogen dioxide. Okay. You don't need to balance these, so just know the process. And then that nitrogen dioxide is what causes that brown haze that you see with photochemical smog. A lot of times that brown haze will just kind of like sit right over the city. And the things that kind of make it happen include things like if it's really sunny out and warm and it's dry and there's lots of people driving, that all contributes to the formation of this photochemical smog, which again is called brown air smog because of the color. Some of the things that are produced as a result of this process, it produces secondary pollutants. So things continue to react in the atmosphere, and eventually can make ozone and PANs, which are those peroxysyl nitrates, nitrogen dioxide. Those are all pictured and discussed on page 423 in your book. So I'd like you to become familiar with that. The other kind of smog I mentioned earlier is industrial smog. And industrial smog is associated with sulfur. It's also called gray air smog. And what happens is the carbon in the coal converts to CO2 and CO, and it also it emits soot. And soot is a type of suspended particulate. It's basically unburned parts of the coal. And that coal, the sulfur in the coal, will react with the atmosphere conditions at the time. And one thing about the sulfur in the coal, there's different kinds of coal. There's anthracite, bituminous, and then peat and lignite. Peat and lignite technically aren't a coal because they haven't been solidified and had been exposed to enough pressure to make a rock. So these are kind of out of the picture. But there's two other kinds of coal. There's anthracite and bituminous. Bituminous is the most abundant coal on the earth, and it also has the most sulfur in it. Anthracite is not so abundant because it's really old and there's not a lot of sulfur in it and has a high heat holding capacity. Out of all the different types, anthracite's the best, but it's also the most expensive and hardest to get. So the most common is bituminous, but unfortunately it has lots of sulfur in it. And this sulfur will react with oxygen in the atmosphere to form sulfur dioxide, which then reacts with water, eventually to form sulfuric acid. It can also react with ammonia in the atmosphere, which then makes ammonium sulfate. And ammonium sulfate and soot together make gray air smog. You'll have to know this process. So industrial smog and photochemical smog are both the product of the reaction of secondary pollutants reacting with each other in the atmosphere. Okay. Factors that influence smog formation, we've already talked about a little bit. But even urban buildings, I forgot to mention that. I talked about topography and like valleys and mountains, but even buildings, because buildings in an urban area will, slow down wind speed and then reduce dilution of those pollutants or dispersal of those pollutants because it's slowing down the air, the movement of the air, the wind speed. Hills and mountains, we already talked about. There's a reduced flow of air in valleys below them, and it allows the air pollutants to kind of build up from the ground up. And then even high temperatures, because high temperatures are a catalyst to make reactions go faster. And that's what makes the smog. Okay, I'm going to end right there about smog. Make sure you read over in your book. It starts on page 421 and goes all the way to 425. So make sure you know and are very familiar with those pages.